She decided that she would like to do a PhD. That a woman doing a PhD in the Sorbonne was just unheard of. But just like students today, she needed to find a subject. What does she want to work on? And the whole country was aglow with two discoveries. One made by Wilhelm Röntgen in Germany, in which he took a cathode ray tube, a glass tube which is electrified, and he found and emitted from this tube was an X-ray. And one of the most famous photographs in science is the hand photographed by the first X-ray machine. The other discovery was by a man named Becquerel, Henri Becquerel. And he was a third-generation scientist and sort of did a lot of different things. He was interested in rocks that absorbed energy from the sun and perhaps re-radiated. So it's fluorescence and phosphorescence. But he accidentally found, and this was sheer accident, that some uranium salts that he had inherited from his father was a photographer, and uranium salts were made to enhance photographs, when put into a drawer next to some photographic film, all wrapped up in black paper, that this film became exposed, although there's no light around any place. And he said, is it possible that, like Röntgen's X-ray, something came out of this uranium and exposed the film? Now, this was a simple experiment to do compared to Röntgen's X-ray machine. All you have to do is take some of his crystals, put it onto a photographic plate, which is completely hidden from light. And as soon as he did that, all of France was aglow and said, oh, we have another ray. So you had the Röntgen ray, X-rays, and you had the Becquerel ray. And Madame Curie, she is now Madame, and she's now a Curie, decided that that interested her more than the X-rays. So she got a number of elements. The number of elements at that time were fairly small. She identified thorium as a radioactive element. So now we have uranium and we have thorium. And she was looking at a lot of different minerals, and she ran across one mineral called pitchblende. Now, in her studies with uranium, she made the discovery, of which was part of her Nobel Prize, that the uranium gave off something we call the uranium ray, which was not affected. The uranium, no matter what you did with it, you could heat it, you could cool it, you could acidify it, you could pulverize it. But the amount of radiation coming off was only a function of the number of uranium atoms. This was a major, major discovery, because it told her it's not chemistry. Because in chemistry, you have things that smell different, different colors, different viscosities, but no matter what you did to this crystal, it was only the uranium that counted. So that was her first insight, that there was something inside the uranium atom that caused this radiation. And this is why I said she laid the first brick. The second wonderful insight was that once she knew that it was uranium, she found a mineral called pitchblende, originally coming from Bohemia. And the radiation in this pitchblende was far greater than the number of uranium atoms that she could calculate and measure in there. And she concluded there must be something else radioactive which has never been discovered before, because there were in pitchblende there were about 30 different types of atoms. And so she had a quest to find this unknown radiation. Now, she had tremendous help in doing this from her husband, Pierre, because years and years before they had met, he and his brother had invented a machine called an electrometer. It was an electric machine in which if you have ionized molecules, a molecule like in air that has a charge on it, it would give you an indication. Now in radioactivity, you produce charged particles. So instead of using a photographic plate like Becquerel did, she was able to use Pierre's electrometer on every sample and determine how much radioactivity it was. So now she would divide the sample in two and treat it one way, treat it another way, treat it a third way, and see if the radioactivity increased or decreased. And this was a laborious job, but at that point, her husband got so interested in that experiment, he joined her. And so now we had years and years of being able to trace the new elements that you found in pitchblende. The first one she found was polonium, named after her beloved country, Poland, and the next one was radium. At that point, when she had these two elements, and she hadn't purified them, but she could identify them and name them, but the Nobel Committee in 1903 awarded her and Pierre and Becquerel, the three of them, a Nobel Prize. Now you might think at that point she would sort of, rest on her laurels, but she and Pierre went through incredible, long extractions to be able to purify radium and polonium. And of course now we know that uranium, the common everyday uranium, when it decays, it has a family of decaying, becomes radium, and then it becomes polonium, but has a very short half-life, the half-life that Rutherford had actually first described, and finally goes to lead. And in 1911, Madame Curie received a second Nobel Prize in chemistry for the work that she and Pierre did in isolating the two new radioactive elements, radium and polonium. She was the first person to get two Nobel Prizes and the first woman to get a Nobel Prize on her own. It was just a marvelous time.